Welcome back everyone. In this video, we can discuss about implicants in K Map and its variants. Let's discuss about the definition of this implicants and about its variants first. Okay, the first definition is about implicant. A group of ones which are adjacent and can be combined in a K Map is called an implicant. Grouping of ones which are present in an adjacent cells in a K Map that group form an implicant. Grouping of ones is valid in case of min terms. Similarly, grouping of zeros is valid in terms of max terms. Right? So the definition is given here based on min terms. We can consider the same definition or implicants in case of max terms also. Okay, so here grouping of ones which are adjacent in a K map is called implicant. Now we can consider different variants of this implicant. Next is about prime implicant. Prime implicants are actually the subset of implicants, right? The biggest groups of ones which can be circled to cover a given one is called a prime implicant. In case of this implicants, certain implicants form the biggest group of ones. The biggest group of ones which can circle a particular one or which is generated in order to cover a particular one in the K map is called the prime implicant. This is the definition. Biggest group of ones which is used to cover a particular one in the K map is called the prime implicant. Okay, among the implicants, the biggest group of one, biggest groups of one which cover a particular one in the K map is called the prime implicant. Next is about the essential prime implicant. The prime implicant which is the only cover of some ones in the essential prime implicants. Not this. Essential prime implicant is a subset of prime implicant. Means this essential prime implicants are always the biggest group of ones. So essential prime implicant means such a biggest group of ones, that is a prime implicant, which is the only cover of some ones, only one cover. The group generated in order to cover a particular one, right? But this one is the only one such group. Then we can say that particular prime implicant as essential prime implicant. That particular prime implicant is essential in order to include a particular one in the K map. Okay, next is about redundant prime implicant. The prime implicants for which each of its min term is covered by some other essential prime implicants, then we can say such implicants, prime implicants as redundant prime implicants. For a biggest group, that is for a particular prime implicant, if its group members are part of some other essential prime implicants, then we can say such a prime implicant is redundant one. All these definitions become clear with some examples. Okay, we need to care about the prime implicants as well as the essential prime implicants in order to minimize using K map. Okay, so for simplifying the given form, we need to consider or we need to care about the prime implicants and essential prime implicants only. Don't want to consider never this implicant set. Okay, so consider one example. This is a K map with values are given here in these cells. Okay, consider certain groups. A group like this, a group like this, and one more group possible here, this one, this red one. Okay, now identify which are the prime implicants All these three are prime implicants. Why? This is the biggest group that can cover maximum adjacent ones. This one can maximum halt these two ones, this blue one. And for this blue one, it can maximum hold these two ones. So these two are the biggest prime implicants possible here. And one more, this red can hold these two ones. So again, this one is a biggest group possible here. So these three actually prime implicants means in this K map, within this situation, total 3 prime implicants are possible, like this. Right. So from this, what about this blue? This blue is essential here in order to include this particular one. Similarly, this blue again is essential here in order to include this one, because no other group is available here in order to include or in order to group this one. This is the only one essential prime implicant that can cover or that can circle this particular one. Similarly here, this is the only one prime implicant, it can cover this particular one. But the condition is different in case of this red one. Its members are this one and this one. This particular one is already part of this essential prime implicant. This one is already a part of this particular essential prime implicant. Right. So from this it is clear that this red one is a redundant one. Right. So number of essential prime implicants here it is this blue one and this blue one. Total 2 essential prime implicants are present. Total 3 prime implicants are present. Among these, 2 are essential and the remaining one, that is the red one, is the redundant prime implicant. Okay. Next, another example, consider different prime implicants. Try to make different prime implicants in this given K map. This one is the biggest group that can cover all these one or that can circle all these ones together. So this is a prime implicant. Another prime implicant can cover all these four together. The biggest group. Here it can cover all these four ones. So this is again a prime implicant. And for including this one, we can consider a group like this. This is an implicant, right? But is this the prime implicant? No. This will violate the definition of prime implicant. Prime implicant means the largest, the biggest group that can cover a particular one. This particular group is not the biggest one that can cover this particular one, right? This is not the biggest one. Another group is possible that can cover a member of 4. So this is the biggest group that can cover or that can circle this particular one. So this now form a prime implicant. The previous one, this is not a prime implicant. This is simply an implicant, a group of ones. But this is not the prime implicant because here we can possible with some other biggest group like this. It can cover this one also. Right. Now consider another group, this green one. This is again a prime implicant, the biggest group that can cover these 4 different ones. Okay, now we can identify all these 3 from this given K map. Number of prime implicants. From this circles, it is clear that total 1, 2, 3, 4, 4 prime implicants are valid here. Among these, which are essential prime implicants, we can also represent using this EPI. And for redundant prime implicant, we can use this RPI, redundant prime implicant. Okay, among these, this particular blue group is essential. Why? This is essential for including this one, this particular one right? So this is essential here. Next is this one. This group is essential for including this particular one in a circle. Okay, this form an essential prime implicant here because this is essential here for including this one. Okay, and in this case, this is essential in order to include these two ones in a biggest group. Okay, so from this it is clear that this blue one and this maroon one, these three are essential prime implicants. And what about this green one? For this green one, consider its members. These two ones and these two ones are the member of this biggest green group, right? For this green group, this one is already a part of this essential prime implicant. This one is again a part of this essential prime implicant. And these two ones are already part of this blue prime implicant, essential prime implicant. Okay, that means this green one here it is actually a redundant one. So from this it is clear that total number of essential prime implicants available here it is 3. This blue one and this maroon one. And number of redundant prime implicant is actually 1, the green one, because its members are actually a part of already covered by some other essential prime implicants. All of its members are already covered by some other essential prime implicants. That is why we can say this green group as redundant prime implicant. So this was a GATE question asked in 2018 GATE exam, and this one is actually a numerical type question. And the question is like this: a Boolean function f with variables p, q, r, s, and this is actually a SOAP form with minterms and don't cares. The question is to find the number of essential prime implicants possible in this function. We need to get the number of essential prime implicants possible in this K map. So the K map representation for the given function is like this. 0 is a minterm, so mark 1 for 0, and 2 is again a minterm, mark 1 for 2. 3 is a don't care, so mark cross. That means mark don't care here for 3. 5 is a minterm, mark 1. 7 is a minterm, mark 1. And 8 is a don't care, so mark don't care here. 9 is a minterm, so mark 1 here. 10 is a don't care, mark cross here. 11 is a minterm, mark 1 here. 12 and 14 are don't cares, mark don't cares here. So in case of don't cares, if the don't cares are present along with the main terms while making groups, we need to consider this don't cares only if this don't cares help us to make biggest group. Otherwise, simply discard that don't case. We don't want to consider or group all the don't case. This is not a necessary case. We need to consider this don't case only one if it helps us to make biggest group. Otherwise, simply discard that don't case. So, consider or try to make different groups. This is a biggest group. This biggest group, circle this one, these two ones. And while combining these two don't cares, here it form a biggest group that can cover these two ones. Again, while combining these two don't cares along with these two ones, here it form a biggest group of 4 members. That group is essential for including these two ones here. Right? So, this is another group, the yellow one. Another group. The group contains only 2 members. This one is essential here for holding these two ones here. Now we can consider some more prime implicants like this. This is a prime implicant, valid prime implicant. But this is essential here? No way. Why? Because this maroon one is essential here, because this maroon one is essential here for including this particular one. So in that sense, this blue is redundant, because this one is already a member of this maroon essential prime implicant. So this blue is not necessary here. Right. So consider another prime implicant like this. This is a prime implicant. Sorry, this is not a prime implicant. This is simply an implicant, because this is not the largest group possible here. The blue one is the largest possible group that include the adjacent ones here. Okay, so we don't want to consider such group, this green group here. Simply discard this. So these three groups are enough here for covering all the ones possible in this given K map. Okay, so the question is identify the number of essential prime implicants possible in this given function. This blue one is an essential prime implicant because this is needed for covering these two ones. And this yellow one is essential here for covering these two ones, and this group form the biggest group of four ones. Again, this group of two ones. This is again an essential group. This is the biggest one. Here, the maximum possible members of this group is 2. So, this is the maximum possible group with 2 members that can hold 2 ones here. Right. So, total number of essential prime implicants possible here in this group is 3. So, this is the right answer for this question. Okay. Thank you.